Hello, Math 2 students. This is lesson or notes 1. Whoops. Sorry about that. Let me get my pen here. There we go. This is lesson or notes 1.4.3. So this is Wednesday, 4th week, first grading period. And this is on triangle inequalities. This lesson is going to be shorter than yesterday's. Yesterday was a lot of information, a lot of exercises to do. This one's going to be a lot shorter. There are a couple different things I need you to know, and then that's pretty much going to be it. There's going to be some practice, and then there's a classwork that we'll work on when you come to the live lesson. So triangle inequalities. We're just looking at triangles today, and we're looking at the sides of the triangles to decide whether it's possible for those sides, for those lengths to make up a triangle, basically is what we're doing. So I have three segments here, a green, a blue, and a red. And if I were to ask you, can I make up a triangle with these three segments? And, and you had the tools that I have, what you could possibly do is just kind of move those together and see if you could actually make a triangle with them. And I come pretty close. I can actually kind of move this over a little bit to make that meet up. So yeah, I can come pretty close. And so I can see that I could create a triangle with these sides. If I took away the red side and I decided to make it a lot shorter than it is, and I said the same thing, can you make a triangle with these three sides? And then you move that red side over. I don't think there's any way, I just made the green one longer. I don't think that there's any way that we could move the red and the green together. Maybe, no, I don't think so. I think what would happen is that they would end up flat on that blue side and they don't join to make a triangle. So there are certain lengths that will make a triangle, and then there are other lengths that won't create a triangle. So that's kind of what this is all about today, is can we make a triangle with these three lengths of these three segments? So that's really what this lesson is about. So just to set this up, let me grab my pen again. And it says you should already know this. So this is I'm assuming this is an 8th grade math concept or a Math 1 concept, I'm not sure. But the smallest side is always across from the smallest angle, and the largest side is across from the largest, should say angle, from the largest angle. What that means is this. See, I've got three different side lengths here. I've got a 4, I've got a 5, and I've got a 6 centimeter. What that means is that the angle that's across from the 4 is going to be the smallest angle in the triangle. Because this is the shortest side, this is going to be the smallest angle. So this red side and this red angle are the smallest. They're the shortest and smallest. So then the middle side, or the one that's not the shortest or the smallest, this one right here, would match up with this angle right here. Okay, and there's always a correlation there. And then the same thing with this side here, and the angle that we think of as being across from it. The blue angle and the blue side are the largest, and then the blue side is the longest. So those kind of correlate with each other. They kind of go together. So that's something that you need to understand. If you know the lengths of the sides, then you can tell the order of the size of the angles as well, and vice versa. If you know the angle measures, you can tell which side is the shortest and the longest as well. We are actually going to skip this example for now. We might come back to this if I feel like we have time, but for now we're going to skip it. It takes a little while to do this problem, and I'd rather come back to it later. So just skip over that for now. Don't mark it out because we might come back to it. Okay, so we're going to look at two different kind of rules or theorems. A theorem in geometry is just a rule that says this is true. if this is true, then this is true. That's what you'll usually see. And this theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. When we talk about the third side, we are talking about the longest side. So third side, longest side. So here's how this works. This is in words, but let me show you how this works. For example, determine if it is possible to draw a triangle with side measures 12, 11, and 17. So this side plus this side, the two shortest sides, 12 plus 11, need to be greater than, not greater than or equal to, but actually greater than 17. Well, 12 plus 11 is 23. 23 is greater than 17, so the answer would be yes, it is possible. That's all there is to that. So you take the two smallest numbers, 5 plus 7, it has to be greater than 9. 5 plus 7 is 12. That is greater than 9, so the answer here again would be yes. So that's all you do. Take the two shortest. If that's greater, it's got to be greater than. So look at this example right here. 1 plus 3 is greater than 4. 4 greater than 4. It is not greater than 4. It's equal to 4. It's got to be a bigger number. Because if you had two side lengths, if you had a 4 here, and then you had a 1 and a 3, and you started moving them down like I did those other segments, they would meet in the middle, because if you had the 1 would be like right here, the 3 would be right here, and this would be 4. They're equal to each other. So the answer here is no. Okay, let's look at the next one. 5.2 plus 5.5 has to be greater than 10.1. 5.2 plus 5.5, that's going to be 7.7. Greater than 10.1? Nope, it is not. So the answer is no. And then our last one, 7 plus 7 greater than 14. 14 is not greater than 14. So again, our answer is no. The only one of these that worked was the first one, the 5, 7, and 9. And then our example up here as well. Let me make sure I'm on the right page here. Yes. Okay, so this is the second type of problem that you need to know how to work. This is if you're given two sides of the triangle and you don't really know if they're the shortest and the longest, or the longest and the middle one, or whatever. So this type of problem, what you're going to be doing is setting up what we call a compound inequality. And this is something you're going to need to know for Math 3 too. You're going to need to understand what a compound inequality is for Math 3. But what it's going to look like is your x is in the middle, so your value you're looking for is in the middle. And then you've got a less than symbol here and a less than symbol here. And then you're going to find this value right here and this one. So A and B are what you're looking for. A is what we call the minimum. And then B is the maximum. And what we're talking about is we're giving a range between two numbers that the third side could be. Okay, so if you're given two lengths of a triangle, like this example down here, and the lengths are 3 and 8, well, that could be the longest side, this could be the shortest side, or it could be, this could be middle and longest. It doesn't matter. Here's how you do this though. What they're asking for is a range of numbers. So they're saying, what could the third side be? Well, it could be, 3 plus 8 is 11. It could be 12, right? Or it could be, let's say it could be 6, but they want the range. So they want you to say x could be between this number and this number. Here's how you do it, okay? So the third side cannot be any larger than the two added together. That would be the maximum, okay? So that is where we're finding that maximum number. So what you would do is you would just add the two numbers together. So I'm going to type this in because you'll probably be typing this in too. Let me see if I can type this. Okay. Oh, that's going to be really big. Hang on. That might be better. Find the maximum by adding the two sides that you have together. And then down here, we're going to find the minimum. It keeps going back to 36. We need to find the minimum by subtracting the two sides. So the two sides that you have, you're going to do two things. You're going to add them together and you're going to subtract them. And so that's going to find the minimum and the maximum. All right, so let's subtract them first because that's going to read left to right. 8 minus 3 is 5. 5 is less than, x is less than, and then we're going to add them together, 11. What that is saying is the third side could be anywhere from 5 to 11, but it can't equal 5 because we don't have the little equal sign under there. Whoops, I didn't mean to do that. It can't equal 5 and it can't equal 11. It's got to be 5.1 and 10.9 or anything in between. Okay, so that's all you do there. So let's see if we've got some examples to work here. Okay, so yeah, given the first two sides, give the range for the third side of an inequality. So remember, it's going to be x here, it's going to be less than there, and less than there. This really means x is greater than, but it doesn't matter. So let's subtract them. 20 minus 15 is 5. 20 plus 15 is 35. That's all you do. Subtract them, add them. Okay? Same thing here. Subtract. 34 minus 22 is 12. Less than, x is less than, and then 22 plus 34 is 56. Same thing here. Let's subtract them. 1. So it could be between 1 and 17. And that's it. That's all you do with that type of problem. All right, let's see if we've got some other, we've got some other examples here. So this was the first type of problem we did, where we're given those 3 lengths and we're asked to figure out if it's possible to have a triangle with those lengths. So I'm gonna, you know what I'm gonna do? I'm gonna do some down here. So number 1, let me get a better pen. All right, number 1, 3, 4, and 5. 3 plus 4 has to be greater than 5. 7 is greater than 5. So my answer here is yes. Number 2, 4 plus 5 greater than 9. 9 is not greater than 9, so the answer here is no. Number 3, 5 plus 6 greater than 12. 11 greater than 12? Nope, answer's no. Let's see. Number 4. Sorry y'all are hearing my phone so much. I'm going to turn it off. All right, number 4. We have 3.5 plus 4.5 greater than 7. Well, that's going to be 8. 8 is greater than 7, so the answer here would be yes. So you get the idea. Number 5. We'll do these real fast. 4 plus 5 greater than 8.5. Yes, 9 is greater than 8.5. So the answer here would be yes. And then the last one, I believe this is a 0.5. Yes. Okay, so the smallest ones are the 0.5 and the 0.6. This is a little bit trickier because it's got these decimals in it. 0.5 plus 0.6 greater than 1.2. 0.5 plus 0.6 is 1.1. That is not greater than 1.2, so the answer would be no on that one. All right, so that's all there is to that. If you're given the 3 lengths, add up the 2 smallest ones. If it's greater than the biggest one, your answer is yes. If it's not, the answer is no. Okay, let's move on to some other type examples. Okay, so this is the second type that we went through, where we subtract the 2 numbers. Let me get a better color here. We subtract the numbers to get this minimum, so that's going to be a 5, and then we add them together to get the maximum. So if I've got 2 side lengths that are 3 and 8, the third side length needs to be greater than 5, but less than 11. All right, number 8. We're going to subtract these, that's 13, and then we're going to add them, that is 37. Subtract, that's going to be 9, add them, 17. Subtract, what's that going to be? 8 and 34. So that's all there is to that. On the next part of this page, mark out number 15, just like X it out or mark it out or something. I don't want to go there with that one. We can look at number 16. What conclusion can we draw from this triangle? Well, first of all, we've got a 61-degree angle, a 58-degree angle, and we can find that third angle by adding together 61 plus 58. That's going to be, that's 110, 119. I'm going to get my calculator out and make sure. I'm not very good at doing this stuff in my head, believe it or not. Plus 58. That's 119. 180 minus 119 is 61. So this is 61. Okay, so what they want us to realize is that if we have, like, if this is side A, this is angle A, and I'm going to put a capital A there. If this is side B, this is angle B. And side C goes with angle C. In fact, I'm going to switch colors. So I'm going to do B, and that side's going to be red. A, I'll leave green, and this side is green, and then we'll do a blue. C, angle C is blue, side C is blue. So that's how they go together, okay? So the red angle, whoops, let me get red. This red angle right here, the 61-degree angle, goes with this red side, okay? This 61-degree angle goes with this blue side. Because you remember how we talked about that before. And then the green angle goes with the green side. Okay, so the blue angle is 61 degrees. The red angle is 61 degrees. If we have two angles that are congruent to each other, their opposite sides, their corresponding sides, are also congruent to each other. So the red side and the blue side are congruent. So the conclusion that they want us to draw is that side B and side C are congruent to each other. So we could say B and C are the same length. Okay. I also don't want to do this part right here, and I think this is the end of the notes. Oh, not quite. Okay. All right, so I want you to mark out this part too. I really just want you to know how to do those two types of problems, and also to know something like this. If you've got two angles that are congruent, their two corresponding sides are also congruent. This last section I think is a little bit confusing, and I want to change something. First of all, I want you to mark out all these things right here, because I don't know why they chose to do greatest to least. Here's what we're going to do. We're going to change this and make it least to greatest, which would be easy, pretty easy to do. I don't understand why they did greatest to least and did these greater than symbols when we just got through dealing with less than symbols. Because on these types of problems, I want you to know that these are always going to be less than symbols. And I don't want you to get confused with these greater than symbols. That's just weird. So let's do this. Let's look at number 11, and let's figure out what this third angle is going to be. I'm going to get my calculator out again. I'm going to add the 70 plus the 35, that's 105, and then subtract that from 180, that is 75. So that means this angle right here is 75 degrees. So if I go least to greatest, my smallest angle is right here. Let me get some colors. This is my smallest angle, and it corresponds to this side. So what you can do is you can kind of just imagine it. It intercepts this side, and this is something that you'll do in Math 3 also. So the side that is the shortest is C. So I would list C first. So C is the first one I would list, and we'll just put a comma. That's fine. Then the next one, in order from least to greatest, is the 70-degree angle, and that goes with side B. So side B would be the next biggest side, or the next largest side. And then the 75-degree angle is the longest one, so that corresponds with side A. So side A would be the longest side. Okay. Well, let's see. This one's asking about angles. It's the same thing. Angle A corresponds to this side that's 9 units. Angle B corresponds to the side that's 12 units. And angle C corresponds to the side that's 5 units. So the angles are also in order, in the same order. So if 5, 9, 12 are in order from least to greatest, well, the 5 unit side corresponds to angle C. So that one would be the one we would list first. And then the 9 unit side corresponds to angle A. And then the 12 unit side corresponds to angle B. So that would be the order of the angles from least to greatest. All right, let's look here. 55 plus 68, and then subtract that from 180, that's 57. So this angle right here would be 57. So that corresponds with side B. So what's the smallest angle? My smallest angle is right here. So that corresponds with side A. So I would list A first. And then the 57 is the next one, so B would be next. And then C would be the longest side. And you could also, you know what you could also do is put like a 1, a 2, and a 3 here if that helps you. All right, and then on this one, they're asking for the angles again. So the shortest side is the 15. So B would be listed first. The middle side is the 17, so that would be angle C. And then the longest side is the 28, so that would be angle A. So that's all we're doing there. All right, and we're done. We made it in just over 20 minutes today. So make sure you have these notes done. Come to the live lesson, and we will be working on the classwork together during the live lesson.